Welcome to Cosmic Whispers, where cosmic mysteries come alive. Your journey beyond the stars begins now. Imagine waking up tomorrow morning to find the moon has simply vanished. Not destroyed, not moved, completely gone, as if it never existed. In the first moments following this cosmic catastrophe, Earth would experience gravitational chaos unlike anything in its 4.5 billion year history. The moon's gravitational pull extends far beyond creating our familiar tides. With a mass of 7.34 times 10 to the 22nd kilograms, our lunar companion exerts a force that affects every drop of water, every grain of sand, and every living creature on our planet. The moment it disappears, this gravitational anchor would release its hold, sending shockwaves through Earth's systems. Within minutes, coastal regions worldwide would witness the most dramatic tidal event in human history. The ocean waters, no longer held in their lunar-influenced patterns, would surge and retreat unpredictably. Current tidal ranges, which can reach up to 53 feet in places like the Bay of Fundy, would collapse into chaotic, irregular waves. Coastal cities from New York to Tokyo would face immediate flooding, as billions of tons of seawater redistribute themselves according to Earth's gravity alone. The initial gravitational release would create what scientists call a tidal bore, a wall of water traveling at speeds exceeding 30 miles per hour. These weren't ordinary waves, but gravitational tsunamis, carrying the accumulated energy of lunar influence suddenly set free. Maritime traffic would face unprecedented dangers as ships designed for predictable tidal patterns suddenly navigate, waters behaving according to entirely new rules. But the chaos extends beyond our oceans. The moon's gravitational field also affects Earth's solid surface, creating land tides that raise and lower the ground by up to 20 inches daily. Without lunar influence, this constant flexing would cease abruptly, potentially triggering seismic activity along fault lines worldwide. Geological stress patterns maintained for millions of years would suddenly shift. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. The atmospheric effects would prove equally dramatic. Earth's atmosphere experiences lunar tides just like our oceans, with air masses rising and falling in response to the moon's position. Without this influence, global weather patterns would begin shifting immediately. The jet streams, those high-altitude rivers of air that control weather across continents, depend partly on lunar gravitational effects. Their disruption would send weather systems into unprecedented confusion. Scientists studying tidal phenomena through projects like the Global Ocean Observing System would record measurements unlike anything in their databases. Tide gauges from Sydney to San Francisco would register readings that break every known pattern, while satellite altimetry from missions like Jason 3 would capture the ocean's violent reorganization from space. The psychological impact on humanity would be profound. For over 300,000 years, modern humans have lived under lunar cycles that govern everything, from sleep patterns to reproductive cycles. Archaeological evidence shows our ancestors tracked lunar phases 30,000 years ago, creating calendars carved in bone and stone. This deep connection to lunar rhythms influences circadian biology in ways we're only beginning to understand. Emergency response systems worldwide would activate as coastal evacuations begin. The Global Positioning System, which relies on precise Earth rotation measurements influenced by lunar gravitational effects, would require immediate recalibration. Communication satellites would need orbital adjustments as Earth's gravitational field subtly changes without its lunar partner. Within hours, the initial chaos would give way to a more ominous realization. This catastrophe represents only the beginning of Earth's transformation into a fundamentally different world. 24 hours after the moon's disappearance, Earth would begin exhibiting behavior that transforms it from a stable, habitable world into a chaotic, wobbling sphere. The disaster unfolding would make the initial tidal chaos seem manageable. By comparison, Earth's axial tilt, currently maintained at a stable 23.5 degrees by lunar gravitational influence, would begin fluctuating wildly. This phenomenon, known as obliquity variation, normally changes by only about 2 degrees over 41,000 year cycles. Without the Moon's stabilizing presence, computer models predict variations of up to 60 degrees could occur over geological timescales, with noticeable changes beginning within months. The first signs would appear in Earth's rotation. Our planet currently spins with remarkable consistency, completing one rotation every 23 hours, 56 minutes, and 4 seconds. The Moon's gravitational torque helps maintain this stability through a phenomenon called tidal locking, resonance. Without lunar influence, Earth's rotation would become irregular, with days randomly varying in length by minutes or even hours. This rotational chaos would devastate global timekeeping systems. Atomic clocks, the foundation of modern navigation and communication, would require constant adjustment. The International Earth Rotation and Reference System Service, which monitors our planet's orientation in space, would face unprecedented challenges tracking these chaotic changes. Climate systems worldwide would begin their descent into unpredictability. Earth's current climate zones exist because solar energy distribution depends on axial tilt stability. The Arctic receives less solar radiation than the equator due to our planet's consistent 23.5-degree tilt. As this angle begins fluctuating, temperature patterns that have remained stable for millions of years would collapse. Within months, regions experiencing polar night might suddenly face direct sunlight, while tropical areas could plunge into extended darkness. The Sahara Desert might freeze, while Antarctica experiences unprecedented melting. These aren't gradual climate changes, but violent swings that would make adaptation nearly impossible for most life forms. Ocean currents, the planet's thermal regulation system, would face complete disruption. The Gulf Stream, which transports 30 times more water than all the world's rivers combined, depends on consistent temperature and salinity gradients. As climate zones shift unpredictably, these massive conveyor belts of warm and cold water would break down, eliminating the thermal buffering that keeps Earth's climate habitable. Agricultural systems would collapse within growing seasons. Crops, evolved under predictable seasonal patterns, would face random temperature swings and irregular daylight cycles. Rice, which feeds over half the world's population, requires specific day-length triggers for flowering. Wheat depends on winter vernalization, followed by predictable spring warming. These biological rhythms, refined over millions of years of evolution, would become meaningless in a world without seasonal stability. The cryosphere, Earth's ice systems, would experience catastrophic instability. Polar ice caps currently maintain their mass through predictable seasonal accumulation and melting cycles. With random climate swings, ice sheets might experience simultaneous massive melting and freezing, creating chaotic glacial behavior that could alter sea levels by dozens of feet within decades. Atmospheric circulation patterns would enter permanent chaos. The Coriolis effect, which creates consistent wind patterns due to Earth's rotation, would become unreliable as rotational speed varies. Hurricane formation, tornado development, and monsoon patterns would become impossible to predict or understand. Ecosystem collapse would accelerate as species face environmental changes far exceeding their adaptive capabilities. Migration patterns timed to seasonal changes would become suicidal journeys. Arctic terns, which migrate from Arctic to Antarctic annually, would find their navigational instincts leading them into lethal climate zones. The magnetic field, generated by Earth's rotating iron core, would begin weakening as rotational irregularities disrupt the geodynamo effect. This magnetic shield protects us from deadly solar radiation and cosmic rays. Its degradation would expose the surface to radiation levels capable of sterilizing most life forms. As Earth wobbles through its second month without the Moon, the planet would be transforming into an unrecognizable, hostile world where survival becomes increasingly impossible. 3 months into Earth's moonless existence, the planet's marine ecosystems would be experiencing a mass extinction event rivaling the asteroid impact that killed the dinosaurs 66 million years ago. The disappearance of tides represents far more than a minor inconvenience. It marks the elimination of one of Earth's most productive and diverse biomes. Tidal zones, those narrow bands of coastline between high and low tide marks, contain some of the most biologically productive ecosystems on Earth. These areas, covering approximately 200,000 square miles globally, support over 5,000 species of marine organisms. Without lunar-driven tides, these zones would either remain permanently submerged or permanently exposed, creating ecological dead zones where complex food webs once thrived. The twice-daily tidal cycle drives what marine biologists call the tidal pump, a system that moves nutrients, oxygen, and organisms between terrestrial and marine environments. This pump delivers approximately 14 billion tons of organic matter annually to coastal ecosystems. Kelp forests, seagrass beds, and coral reefs all depend on tidal nutrient delivery for survival. Without this constant refreshment, these underwater gardens would begin dying within weeks. Intertidal organisms face immediate extinction. Barnacles, mussels, sea anemones, and thousands of other species evolved specifically to survive the twice-daily transition between air and water exposure. Their physiological adaptations, including specialized proteins that prevent cellular damage during exposure changes, become meaningless in a tideless world. Entire taxonomic groups would vanish as their ecological niche simply ceases to exist. With the elimination of tidal mixing would create oceanic dead zones on an unprecedented scale. Tides currently mix surface waters rich in oxygen with deeper waters containing nutrients, creating the circulation necessary for marine life. Without this mixing, coastal waters would stratify into layers with oxygen-depleted depths and nutrient-starved surfaces. The resulting anoxic conditions would kill most marine life within months. Fish populations would face catastrophic collapse as spawning cycles tied to tidal rhythms fail completely. Pacific salmon, whose reproductive success depends on precise tidal timing for river entry, would experience immediate breeding failure. Grunion fish, which spawn exclusively during specific tidal conditions along California beaches, would face instant extinction. These aren't isolated examples. Over 60% of commercially important fish species depend on tidal cues for reproduction. Estuaries, where rivers meet the sea, would transform from biodiversity hotspots into biological deserts. These areas currently support 75% of commercial fish species during some portion of their life cycles. The complex salinity gradients created by tidal mixing provide crucial nursery habitats for juvenile marine organisms. Without tidal influence, estuaries would become either purely freshwater or purely marine environments, eliminating the transitional zones that support such rich biodiversity. Coastal bird populations would face starvation as their primary food. Sources disappear. Shorebirds like sandpipers, plovers, and turnstones depend on intertidal invertebrates for survival. The red knot, which migrates 8,000 miles annually to feed on horseshoe crab eggs during specific tidal periods, would lose both its food source and timing cues. Over 1 billion migratory birds that depend on intertidal feeding areas would face extinction. The economic impact would devastate coastal communities worldwide. Global fisheries, worth over $150 billion annually, would collapse as marine food chains break down. Oyster, mussel, and clam farming, industries worth billions of dollars, would become impossible without tidal water exchange. Coastal tourism, dependent on healthy marine ecosystems, would vanish as beaches transform into lifeless zones. Marine mammals would struggle with navigation and feeding patterns disrupted by the absence of tidal currents. Whales use tidal flows to assist in migration and feeding, while dolphins depend on tidal pools for hunting. The complex three-dimensional ocean currents created by tidal forces provide highways for marine life movement. Without them, the ocean becomes a more difficult and dangerous place to navigate. Phytoplankton, the microscopic plants that produce 50% of Earth's oxygen, would face severe stress as ocean mixing patterns collapse. These organisms depend on nutrients brought up from deep waters through tidal and current action. Their decline would not only affect marine food chains, but also threaten the atmospheric oxygen levels that sustain all terrestrial life. By the end of the third month, Earth's oceans would be well on their way to becoming biological wastelands, setting the stage for even more catastrophic changes to come. 6 months after the Moon's disappearance, Earth's biological systems would be experiencing a comprehensive breakdown that extends far beyond marine ecosystems. The elimination of lunar cycles would trigger a cascade of evolutionary failures, affecting virtually every living organism on the planet, from microscopic bacteria to complex mammals. Circadian rhythms, the internal biological clocks that govern life processes, would face unprecedented disruption. While many organisms synchronize primarily to solar day-night cycles, lunar rhythms play crucial roles in reproduction, migration, and feeding behaviors across thousands of species. These circa-lunar rhythms, operating on 29.5-day cycles, have evolved over billions of years to coordinate with lunar phases. Coral reefs would experience reproductive catastrophe during what should have been spawning season. Over 100 species of coral coordinate their reproduction with lunar cycles, releasing eggs and sperm simultaneously during specific moon phases. This synchronization, essential for successful fertilization in the ocean's vast waters, would completely break down. The Great Barrier Reef, already stressed by climate change, would face additional pressure as reproductive failure prevents recovery of damaged coral populations. Marine worms provide a dramatic example of lunar dependency. Palolo worms spend most of their lives in coral crevices, but during specific lunar phases, they release reproductive segments that swarm to the surface for mating. Without lunar cues, this precisely timed behavior would cease, leading to reproductive failure and population collapse. Similar patterns exist in over 50 species of marine worms worldwide. Nocturnal mammals would face navigation disasters as they lose their primary celestial compass. Many species, including bats, use lunar light for navigation during foraging. Flights. The predictable lunar cycle helps these animals plan feeding schedules around optimal light conditions. Without this reliable light source, their hunting efficiency would plummet, leading to malnutrition and population decline. Human reproductive cycles would experience subtle but significant disruption. While the connection between lunar cycles and human menstruation remains scientifically debated, historical evidence suggests some correlation existed before artificial lighting disrupted natural light exposure. Women in pre-industrial societies often showed menstrual synchronization with lunar phases. The complete absence of lunar cycles would eliminate whatever natural rhythmic cues still influence human reproduction. Plant reproduction would face chaos as lunar-influenced processes break down. Many plant species, particularly in tropical regions, coordinate flowering and seed release with lunar cycles. The lunar periodicity helps ensure optimal conditions for pollination and germination. Coffee plants, which constitute a multi-billion-dollar global industry, show lunar-influenced growth patterns that affect bean production timing. Insect populations would experience reproductive timing disasters. Many species coordinate mating, swarms with lunar phases, using moonlight levels as environmental cues. Mayflies, midges, and various moths depend on predictable lunar brightness for successful reproduction. The elimination of lunar cycles would desynchronize these events, reducing successful mating and causing population crashes that would ripple through food webs. Tidal pool organisms would face evolutionary obsolescence as adaptations refined over millions of years become meaningless. Fiddler crabs change color according to tidal timing, growing darker during low tide exposure and lighter during submersion. Their internal clocks, synchronized to both solar and lunar cycles, would lose half their environmental cues, causing behavioral chaos that reduces survival rates. Migratory species would lose crucial navigational references. Sea turtles use lunar brightness reflecting off water surfaces to locate suitable nesting beaches. Without consistent lunar cycles, females would struggle to find appropriate nesting sites, leading to reproductive failure across multiple species. The loggerhead turtle, already endangered, would face additional pressure from navigation difficulties. Agricultural productivity would decline as lunar-influenced growth patterns disappear. While scientific evidence for lunar agriculture effects remains limited, many traditional farming practices worldwide coordinate planting and harvesting with lunar phases. The elimination of these cycles would require complete revision of agricultural timing in regions where such practices remain common. The psychological effects on humans would intensify as lunar rhythms disappear from cultural and religious practices. Countless festivals, ceremonies, and cultural events worldwide coordinate with lunar phases. The Islamic calendar, Hindu festivals, and many indigenous celebrations depend on lunar timing. The complete absence of lunar cycles would disrupt cultural practices that have provided social cohesion for thousands of years. As Earth approaches its first full year without the Moon, the cumulative effect of these biological disruptions would create cascading ecosystem failures that threaten the planet's ability to support complex life forms. 1 year after the Moon's disappearance, Earth would be transforming into a fundamentally different planet, one increasingly hostile to the life forms that evolved under lunar influence over billions of years. The cascading effects would create a world where survival becomes an ongoing struggle against chaotic, unpredictable environmental conditions. Earth's axial wobble would now exhibit dramatic variations that make long-term climate prediction impossible. Computer models suggest that without lunar stabilization, obliquity variations could reach extremes of 60 degrees or more over thousands of years. This means regions currently enjoying temperate climates could experience everything from Arctic conditions to tropical heat within centuries rather than geological ages. The length of Earth's day would continue its irregular evolution. Without lunar tidal braking, which currently slows Earth's rotation by 2 milliseconds per century, our planet would gradually spin faster. However, the process would be chaotic, rather than steady. Days might randomly vary between 20 and 26 hours, making biological adaptation nearly impossible for most species. Atmospheric dynamics would create permanent weather chaos. The jet streams, those high-altitude wind rivers that control weather patterns across continents, would lose their stability as Earth's rotation becomes irregular. This would eliminate predictable weather patterns, replacing them with violent, sudden climate shifts that could bring blizzards to deserts and heat waves to polar regions within weeks. Ocean circulation would collapse into new, unpredictable patterns. The thermohaline circulation, which currently transports heat from equatorial regions to polar areas, depends on consistent temperature and salinity gradients. With chaotic climate swings, this global conveyor belt would break down, eliminating Earth's primary climate regulation mechanism. Regional temperatures could vary by 50 degrees Celsius or more between seasons. The magnetic field would weaken significantly as Earth's irregular rotation disrupts the geodynamo effect in the planet's core. This magnetic shield currently deflects 99% of harmful solar radiation. Its degradation would expose the surface to increasing levels of cosmic rays and solar particles, making survival difficult for most life forms and potentially sterilizing large areas during solar storms. Evolutionary pressure would reach levels not seen since the Permian-Triassic extinction event 252 million years ago. Species adapted to predictable seasonal changes would face random environmental conditions that exceed their adaptive capabilities. Only the most generalist organisms, those capable of surviving extreme environmental variations, would have any chance of long-term survival. Human civilization would face unprecedented challenges requiring complete reorganization of society. Agriculture would become nearly impossible without predictable seasons, forcing humanity toward controlled environment farming or underground cultivation. Coastal cities would remain uninhabitable due to chaotic water level changes, driving massive population migrations inland. The psychological toll on human society would prove devastating. Humans evolved under consistent lunar cycles that influenced sleep patterns, reproduction, and social organization. The absence of predictable monthly rhythms would disrupt circadian biology in ways we're only beginning to understand. Mental health issues related to temporal disorientation would become widespread. Navigation systems worldwide would require complete redesign. The global positioning system relies on precise Measurements of Earth's rotation and orientation. With chaotic rotational changes, maintaining accurate positioning would become exponentially more difficult, affecting everything from aviation to shipping to emergency response systems. Scientists project that within several thousand years, Earth's obliquity could vary so wildly that polar ice caps might completely melt during extreme tilts, only to refreeze as the axis shifts again. These dramatic ice age cycles would make large-scale ecosystem establishment impossible, keeping most of the planet in a state of constant environmental flux. The ultimate fate of life on moonless Earth remains uncertain, but most models suggest a gradual decline in biodiversity and ecosystem complexity. While life might persist in protected environments like deep ocean thermal vents or underground ecosystems, the rich, diverse biosphere that characterizes modern Earth would gradually disappear. Perhaps most sobering is the realization that Earth's moon represents far more than a beautiful celestial companion. It serves as the fundamental stabilizing force that makes our planet habitable. Its disappearance would transform Earth into a chaotic, wobbling world where the very concept of environmental stability becomes meaningless, a harsh reminder of how delicately balanced the conditions are that allow life to flourish in our corner of the universe.